Evaluate the following iterated integral. So you have the integral from 0 to the natural log of 5, the integral from 1 to the natural log of 4 of the natural exponential raised to the 3x plus 3y dy dx. So the first thing, since we have a set order here, we're identifying what is our inner integral. So our inner integral is in terms of y, or we're integrating with respect to y here. So we'll start by taking out the inner integral and evaluating it. So I have the integral from 1 to the natural log of 4. And I'm going to separate this exponential here. Remember, if we're adding exponents like this, we can rewrite it as the product of the natural exponential raised to the 3x times the natural exponential raised to the 3y dy. And we're ready to integrate. So we have a constant of 3x multiplied by the integral of 3y divided by 3 from 1 to the natural log of 4, and we're ready to evaluate. So this is the natural exponential raised to the 3x by 3 multiplied by the natural exponential raised to the 3 times the natural log of 4 minus the natural exponential raised to the 3 times 1. So we just want to be mindful here that we need to pull this 3 to the power position of the logarithm in order to apply the inverse property. So this is equivalent to the natural exponential raised to the 3x by 3 multiplied by the natural exponential raised to the natural logarithm of 4 cubed minus the natural exponential raised to the 3. So now we can apply the inverse property, and natural exponential, natural logarithm undo the effects of each other, leaving us with the natural exponential raised to the 3x by 3 multiplied by 4 cubed, which is 64, minus the natural exponential raised to the 3. And so this is the inner integral here, and we're ready to plug this back in to the double integral and evaluate the outer integral. And so we have the natural exponential from 0 to the natural logarithm of 5. I'm going to pull all the constants to the front here. That's going to be 64 minus the natural exponential cubed divided by 3 multiplied by the natural exponential raised to the 3x dx. So everything here in the front is a constant. So you can even pull that to the outside of your integral. And so when we integrate here, we're going to be left with 64 minus the natural exponential cubed by 3 times 3, giving us 9 times the natural exponential raised to the 3x. Again, that extra 3 comes from the antiderivative of the natural exponential. And we want to evaluate here from 0 to the natural log of 5. So this will be 64 minus the natural exponential cubed divided by 9 multiplied by the natural exponential raised to the 3 times the natural log of 5 minus the natural exponential raised to the 0. And again, we're going to need to take this 3 and move it to the power position of our logarithm to apply the inverse property. Anything raised to the 0 goes to 1. And so this is 64 minus the natural exponential cubed divided by 9 multiplied by the natural exponential raised to the natural logarithm of 5 cubed minus 1. So now the natural logarithm undo the effects of each other, leaving us with 64 minus the natural exponential cubed divided by 9 multiplied by 125 minus 1. And so this becomes 124 multiplied by 64 minus the natural exponential cubed divided by 9 And that is our beautiful final answer.